Good morning, Tensor friends. Um, I thought I understood this outer product, but it turns out I didn't. I was getting lost in the tensorial abstract syntax, IJKs all over the place. I think this is a little confusing for beginners because you see a lot of the products, but you don't see very much of this, and it's a little bit confusing. So I started thinking back in time. When I started thinking in linear algebra instead of abstract tensor, the syntax, it just popped right into my little pointy head. So that's what I want to talk about. Let's look at the Desmos matrix calculator. It's kind of fun. All right. So we have here two tensors of rank 1, which we call vectors, right? So in physics, we would say that this vector has contravariant components. So we got two vectors with contravariant components. Now we want to find the dot product of those using matrix notation. All right. So we would say A times B, there's the dot, B, cannot multiply matrices with incompatible dimensions. And you say, well, you dummy, everybody knows that. You got a 3 by 1 and a 3 by 1. You can't do that. Okay. Well, what can we do? Well, back in the days of linear algebra, we would say A transpose, and look what happens. A transpose changes a column vector into a row vector, right? So now we would multiply that by B, and look what we get, just a number. So what's happening here? Well, I just learned this, and this is cool. And the reason it's cool is because the separation of time has been like 40 years. When you transpose a vector, which is a column vector, when you transpose it, you're creating a covector. So a column vector, which is just a vector, transposed becomes a covector. And a covector is called a linear the functional. And a linear the functional acting on a vector B gives a scalar, gives a number. So the product is taking a tensor rank 1, right? This is a tensor rank 1, and it's reducing it to a tensor rank 0. So inner products reduce the tensor rank. All right. Now let's look at the opposite of that. What if we went A times B transpose? Oh my, what happened here? What's this thing? Well, this is a tensor rank 2 in 3 dimensions. A tensor rank 2 in 3 dimensions. So what's that saying? Well, that's saying that this is an outer the product. So an outer product takes a tensor rank 1 here, rank 1, and converted it to a tensor rank 2. So outer products increase the rank and inner products reduce the rank. So that cleared that up completely in my mind. I'm happy. Wanted to share it with you. All right, I'll see you later.